All right, so what we have here is one that's a little bit more interesting. All right, so why is this a little bit more interesting? Well, it's because we've got a binomial which is now being multiplied by our binomial expansion. All right, so what we're going to do is we're going to go ahead and decide how to do this. We've got a couple of different ways. You can use the general term. Another way I want to show you could have used for any of the previous ones as well, is just to kind of write out some of the pieces, right? And so that's what I'm going to show you first, is that we can do that. If you just consider first the expansion of 2x minus 1 to the 6th power, we know that the first piece is going to be 6, 0, 2x to the 6th, and then we're going to add 6, 1, 2x to the 5th times negative 1 to the 1st plus 6, oops, not over, 6, 2, 2x to the 4th, negative 1 squared, right, because that one's going to increase now. And you can keep going if you want, but I'm going to stop here because I actually don't need to go any further. Some of you recognize that here, my x to the 5th term, because I'm looking for the x to the 5th term, I've got one here, right? Now that's just the 2x minus 1 to the 6th power. So that is in existence, and it's right here, but that's not quite the answer to our question. Because remember, this is your 2x minus 1. We need to take all of that and multiply it by x plus 3. So this x to the 5th is valid when the 3 gets distributed to it, right? The 3 is going to get distributed to everything in this whole dang expansion, but most of those aren't important. The only one that's important is when it gets distributed to the one that has the x to the 5th power. So 3, 6, 1, 2x to the 5th, negative 1 to the 1st is important. Okay, but we also have to consider the fact that this x is going to be distributed to every single term. Now that x being distributed to the 6 over 1, 2x to the 5th, negative 1 to the 1st, is not important because x times x to the 5th would give us x to the 6th, which means that we don't have the x to the 5th term anymore. We now have an x to the 6th. So where can that x be distributed so that it gives us what we want? Well, it's going to be distributed to this one right here. Because if I distribute x to that, the x to the 4th, and the x will give me x to the 5th. And so then I need plus x times 6, 2, 2x to the 4th, negative 1 squared. And so from there, I'm just going to work it out, right? I can simplify. I know that the 6, 1 is going to be 6, so that would be 3 times 6 times 2 to the 5th power. 2 to the 5th power is 32. X to the 5th, and then negative 1 to the 1st, of course, is negative 1. And so if I put all that together, it'll be 18 times 32, which some of you can probably do in your head. I can't. So 576. So negative 576 x to the 5th. I'll do the same thing over here. So x, 6, 2, I don't know that one, so I'm going to have to go 6 NCR 2, which is 15. You could have done that on Pascal's triangle, right? Times 2 to the 4th, which is 16, x to the 4th. Negative 1 squared, of course, negative times negative is positive, so that'll go away. So I end up with here 15 times 16, which is 240. So I got 240. X to the x times x to the 4th is x to the 5th. I add those two together and I get my, that should have been 240, I get my final answer of negative 336 x to the 5th. And so there you go. That's your x to the 5th term in the expansion. Now this idea of writing out a few terms can be used in any situation. If you forget the equation, we talked in the last video about the equation tr plus 1 equals nr a to the n minus r b to the r. If you forget that, and it's not in the equation booklet, then you can always just use this idea. If you know the patterns and you know it's 6-0, 6-1, 6-2, if you use those patterns, you should be able to just write it out and you can get that anyway. It does take a little bit longer, but you know, it works no matter what. It'll still work out for you. Even if you needed the 5th or 6th term, it didn't take too long to just kind of write these pieces out. Okay, so you can always do that if you want. Okay, so that's all there is to this one. I guess if you wanted to use this equation, you could use it here, right? You would use that in conjunction with, again, the 2x minus 1 to the 6th power. You would have to recognize that first you want a piece of that that gives you x to the 5th to multiply with the 3. And so you would work it out the same way we did in the previous video to solve for what r needed to be to give you x to the 5th. Or you might already know that. You might be able to figure it out because this is pretty straightforward. And then you're going to have to do that a second time to get the x to the 4th, which is what you need to multiply by the x. So can this be done using the general term? Yes, it can. Is that the easiest way to do it? Well, probably not in this situation. So I hope that was helpful. It only took us about 2 or 3 minutes to get through that whole thing, and we got the same answer. All right, ciao.